I'm developing a project where can be handy for all the technicians that are doing repairs, because this is a pulse voltage injector for finding short circuits on the motherboards. And I have few buttons that you can turn on and turn off. Then you can also adjust the timing of on period and off period, that you can see here. And I would like to make a final product. Welcome back to another project video on my channel. This project really working nice. I tested and it's doing really nice job. When you scan with the thermal camera the short on the motherboard, you get confused with the reflections. So this one will gonna pulse the voltage, so you will gonna look for a component that pulsing on heating up and cooling down. And to make a final product on this project, really come handy the sponsor of this video, NextPCB. When it comes to PCBs, every millimeter matters. And the quality is important too. And if you want to bring your electronic project to life, look no further than NextPCB. And to get your PCB, it's easy. Just go to nextpcb.com, click on Quote Now, upload your Gerber file, select which type of PCB you want, then select how many PCBs you need, which type of board, the thickness of your PCB also, which colors you prefer. Select also all the other things, how you prefer, and what is cool, that if you want your PCB fast, you can select the turnaround time in 24 hours. Select your preferred courier, add to the cart, and place the order. And it's not about the speed or the cost. It's all about the confidence that you're gonna get high quality PCBs. And this is your one-stop solution for PCB manufacturing, assembly, and prototyping. With over 15 years of experience, NextPCBs delivers high-quality PCBs with fast turnaround times. From prototype to production, NextPCBs gives you more than just boards. It gives you an edge with ISO certified quality control. And with the localization of HQ DFM software and an advanced technological online platform, effectively check whether there is hidden issues in your design, select available parts and evaluate the design cost in real time. NextPCB is one-stop solution for PCB fabrications, SMT assembly and component sourcing. NextPCB gives you the edge with competitive pricing, advanced capabilities and free design file review. Whether you are launching your next big product or testing a concept overnight, let NextPCB to turn your circuit dream into reality. So what are you waiting for? Go ahead and visit nextpcb.com and start building your future project today. NextPCB is the industry leader in high-speed, high-precision PCB manufacturing and assembly. And this is how you receive your PCBs from NextPCB. Nicely packed, and the PCBs are high quality made. And for more information about NextPCB, please check the link on the description down below. So NextPCB was really kind to produce for me these PCBs and to sponsor this video. So what I'm going to do is to find all the components that needs to populate this board and build up one board. So let's begin. I really like the color, is a black matte and the quality is really amazing of the PCBs. Yeah, I was doing also from other companies PCBs, but I never managed to find this color, the black matte. Let's carry on finding all the parts that I need for this project and to make sure that they match the footprints which I designed. So yeah, let's carry on finding all the bits that I need for this project. Okay, so in this box I should have almost everything because I bought them and I make also videos. So I say that we need a switch, a power switch over there, and I get different ones. So this one no, and I have this one with no these feet that make more support on the switch. And I have 3 models, shorter and longer. So here I have the both of 2 other models. So let's see which one are longer. This one are shorter, so I'm gonna use a longer one. So one of that one we need for this project, definitely. And let's make sure that is matching the footprint which I designed. So yeah, fit properly over there. So we have the switch. Then we need the 2 MOSFETs over here. So I get 3 different models because I want to use the one that has the lower voltage threshold on the gate. So I'm gonna put them aside and we're gonna look for the data sheets and we're gonna choose that one. We need also 2 LEDs on the bottom here, so we're gonna have one red and one green. So here I have LEDs. Then we need some diodes that drive the gates of the MOSFETs over here. So we have here diodes. Then we need resistors, and here I have a pack of resistors that goes here. Then I don't know if it's in this box, so I put it on a different box. We need an Arduino Nano over here and a battery charger and a connector. So let me find also those ones. So here we go. These are all the components that we need for this project. So we have an Arduino Nano, which is the brain of this project. We have a battery charger with a boost converter from a 1 cell battery to make it to 5 volts to power the Arduino. Then we have the 2 tiny LEDs, one green, one red, diodes and the resistors, the pushy button, the power switch, and banana connectors for the input over here from your bench power supply, and output that goes to inject voltage in the circuit where you want to inject, a buzzer that sound when the pulse is on and then it's quiet when the pulse is off, and the MOSFETs. And the MOSFET which I am using are this one, the CRTD055N03L, which can go up to 30 volts and they can handle around 86 amps or 50 amps. And I choose this one because of the low gate threshold voltage. As you can see here is between 0.8 to 1.8 volts. So at 5 volts, if we are putting 5 volts on the gate, should be almost fully open, this MOSFET. So I'm gonna start first with the SMD components, and I'm gonna use my hot plate station. For that I'm gonna apply some solder paste. I'm gonna put the components in place, and then I'm gonna heat up the hot plate and solder them, and then I'm gonna go to the through hole components. So I'm gonna might do a fast forward on this process when I am applying the solder paste, and I'm gonna solder these components, and then we're gonna come back with a normal video when maybe it's ready to test. So all the SMD components are in place. Just we need to fire up the hot plate and solder these components in place. So let's do also that one. So I set up my hot plate station to 280 degrees because I'm using solder paste which is melting in 138 degrees. So it's heating up now, so let's wait to heat up to the maximum temperature. So now the hot plate reached 138, so I'm gonna put the board on the hot plate, and we're gonna wait for soldering. Right, so now that we have everything soldered, let's give a quick clean to this excess solder paste and flux around the board. I might need different things. I'm gonna try first with the brush to get the heavy stuff down. This is what happens when you solder with solder paste. You're gonna have bulbs everywhere. But no problem, we're gonna clean them well. And it was good if I had ultrasonic cleaner. It's very easy and fast to clean with that one. But no problem, we can also clean in this way. Give a hard clean first with the brush and alcohol. The solder joints looks really nice, I really like them. I see the LEDs, what they are doing over there. They looks cool, also the LEDs. Yeah, a bit more hard cleaning. Let's try with the harder brush, and then we clean with our sponges to remove properly any excess of the flux that rests on the PCB board. I could do also soldering with the hot air station and with the normal soldering wire, but this process is more faster because you apply all the solder paste and then you go there once on the hot plate and everything is cleaning faster. Let's have a look if we can remove these solder blobs around there. Yeah, they're removing, only that they're stuck on flux. Yeah, they stuck only in flux, so we can easily remove all the solder blobs. Look, lots of flux over there. That definitely I can clean it. Okay, so let me clean this board and then I will gonna carry on with the video inspecting the solder joints. So I clean as much I could this board, and now let's inspect together these solder joints. So that one looks cool, this one looks cool, the diodes and resistors looks really cool as well. Let's go down to these resistors, the two for the LEDs and the other ones for the pushy buttons. They looks cool, the solder joints. Yeah, and let's see the last two, the LEDs down here. Also the LEDs looks cool. So the next step is to solder all the through hole parts, like the Arduino Nano, the voltage regulator over here with the charging battery, the battery connector, the on-off slide button, buzzer and pushy buttons over here. So yeah, let's do also that one. So let's start with the battery connector, because once this one is in, we need to put power over here and regulate to make sure that on the output we have 5 volts, because if it's more than 5 volts, this one can go up to 28 volts, I believe, boosting the voltage, but we don't want to fry the Arduino. So we're gonna regulate the 5 volts and then we're gonna carry on with the other solderings, right? So this one and this one I need to solder. Actually no, so this one I can solder. I can keep off the button and I can set up the voltage, and then I can switch on the button. So yeah, I can solder everything. Yeah, let's solder. So I'm gonna go fast forward on soldering, and then we're gonna come back when I need to do all the adjustments and testing this board, right? All the solder has been done, and I clean as much I could, so everything is in place. Only I need to put this one, and this one is mounting with the screws over here. So I have the inputs, this one are, so I'm gonna have a negative input over there, and the positive input over there. Each comes with screws. I had a really hard time to solder these two. They are not that much good quality on soldering, so I don't know, maybe they made for the spade connector. Let me find the pliers and try to tighten those ones a bit. And now it's time to plug a charger and start calibrating the 5 volts, and then once we have the 5 volts, to turn on the power and to see if it's working. Yeah, let's do also that one. So you can see it's powered on, and we have the switch button on off, because I want first to make sure that I'm getting only 5 volts on the output. So I have the negative and the positive over here, and we are getting on the output 6.6, so it's quite high. So we need to reduce that voltage. So let me see in which direction I need to spin this one. So if I go in that direction, the voltage is increasing, so I need to come in this direction to decrease. 6.4, a little bit less. If I had 3 hands, was nice. 5.3, I think it's okay. 5.3, let's reduce it just a little bit. That's 2 less, because we want at least 5.1. yeah, that's good. Right, so if that one's working, I can turn around this board. I'm gonna do a double-sided tape and I'm gonna stick the battery on the right place over there. Let's turn on to see if it's working. So that's on, and I should have start, stop circle, and which is working good. If we start and I go up, so everything is working how should. So this is the off time, because you see increasing the off time over there. So now is long period the off time, more long period off time. We can have very long off time and just a little bit of pulsing. We can increase also the pulsing on. So now is long also the on. Yeah, working how should. Perfect. So now let's try to simulate a short and to see if it's really working, injecting voltage, and to see with the camera if we can find easy the short. So here we go, we have everything ready to test. So I have the boards over here, which is charging the battery and is powering from the battery. What you can see here on the power supply, I have set up my power supply, bench power supply, with 800 millivolts, and with the voltage coming in on these two, passing through this device, going out, and is connected to these two wires. So you can see positive and negative over there. And here I simulate a short circuit on the board over there. And if we can have a look with this one, see around there lots of red spots that you see that, oh my god, something is already shorted, but it's not yet power on. So the reflections are there that make you feel like, is that one shorted or something is wrong over there? So pay attention on that corner when I'm turning on. So now I'm turning on this device, which I developed and made it today. And have a look. The simulated short is the one that pulsing, and we can make it more shorter, the pulse. And you can look for that one when it's beeping. You can also make it longer, the pulse. You can also make shorter the off period. And you look for the pulse. Like that you identify the short circuit on the board. Much easier with this device which I developed and I made it. Yeah, working really good. And I can say that it's really high quality PCBs. I really like them, and this is how looks empty PCB, and this is how looks the project finished with the battery, as I said, here at the back, that get powered by the battery. If I turn it on, it's still working, so it doesn't take any power from your bench power supplies to take current from the bench power supply. It's just switching on and off the power that comes in from the bench power supply and goes out to your motherboard to check the short. And I'm gonna say a big thanks to NextPCB sponsoring this video. And if you're interested on this project and you want to know more about this, please leave your comment down below. And if you're interested and if you want to have one of this one, also please contact me, let me know in the comments down below. We're gonna be in touch and maybe I can provide you this device as well. I hope you enjoyed this video. If so, give me a thumbs up. And if you are new watching this video, please subscribe, activate the notification bell to don't miss my next projects. And until the next one, guys, have a good day and bye bye.